Use the functions f of x and g of x for the exercises below. We are going to evaluate the composition function in both directions and then find the domain of the new function. So for example A, we are trying to find f of g of x. So I'm going to take g and plug it in for x here. So I will have the cube root of x minus 1. That's being cubed. And then we have a plus 1 on the outside. The cube and the cube root are going to cancel each other out. So it looks like we'll have x minus 1 plus 1, which is just equal to x. If I plug in a function like this and I get back the original, it means that those are inverses of one another. And because x doesn't have any restrictions, we don't have any restrictions on the composition function. So the domain here is all real numbers. Let's look at this the other direction. To show that these are in fact inverses, we have to say that this is true going in the other direction as well. So let's find g of f of x. So now I'm going to take this function and plug it in for x here. So I'm going to have x cubed plus 1, like this, under the cube root, and then there's a minus 1 inside. So simplifying, the plus 1 and the minus 1 are going to cancel each other, and so we'll just have x cubed, and the cube root of x cubed is just x. So similarly, the domain here is all real numbers. These are in fact inverse functions of one another because when I take the composition function in both directions, I get the exact same thing. Let's look at a graph of these. The red graph here is the function x cubed plus 1, and then the blue graph here is the cube root of x minus 1. And if you look at the line y equals x, you can see that these two functions are reflected across this green dashed line. That's because when functions are inverses, what we're doing is we're exchanging x and y. And so a point on this graph, for example, is 1, 0, whereas a point on this graph is 0, 1. The x and the y terms are exchanged with one another. So that's why when we were looking at the composition functions, we were getting x back, because that means we started with an original, put it into the red function, then put it in the blue function, so we should get back the original, which is x.